Separation of concern is a software design principle that promotes dividing a system into distinct self-contained modules, where each module is responsible for a specific concern or functionality. The goal is to keep each module focused on a single task, making the system easier to understand, develop, test, and maintain. This is the index or starting point of the application. It does some stuff here like initiating the database, handling errors, and starting the server. It does have a bit of separation of concern where the Express-related stuff is written on the server file and it's imported in the index file. But if you want to test this code, it will be difficult since there is no modularity. So I'll organize this into different functions, and the index file will just load those functions. Let's start by creating loaders, which will contain files that are responsible for handling anything needed to start the application, such as the database, Express, and so on. So now, let me copy the Express-related code inside the server file and paste it into the Express file. Let me close the other open files and paste it here. All right, we have a bunch of errors caused by an incorrect path. So the path should be back to one folder since the Express file is inside the loaders directory. This is prettier, informing us about the end of the line. So let me just make it an auto. I need to restart VS Code to see the change. Now the error is gone. So let me create a new function that is responsible for creating and setting up the Express application. I'm going to put this code inside the function. The import statements should be on top. So let me move this up. And I'm going to remove this since we don't need it anymore. I also need to import Express, so let me import it here. At the end of the function, I need to return the Express app. So I just created a function that returns an Express app and exports it. This will make it easier to do a unit test, and we can simply call this function when you want to load Express. I forgot to add a sync here. Let's do the same thing for functionalities related to the database. So let me head to the index file and take this to the Mongoose file. But before that, I need to import Mongoose first. And I also need to create a function that returns the Mongoose connection. And inside it, let's create the Mongoose connection and paste the code here. Here, I just need the connect function. And let's return the connection. Now I am going to import the config. Let's copy it from the index file, and I will update it to be one folder back. This will also export a function that returns a Mongoose connection, which adds modularity and separation of concern. Inside the index file, let's import both the loaders So the index file is responsible for initiating both the loaders. Now, let me create a function that initiates both the loaders. Let me change this to module.exports is equal to an async function, and it expects the express app as an argument. I am going to call the mongoose loader first, await mongoose loader. Let me also call the express loader. And unlike the mongoose loader, it takes an express app, so let's pass it. Perfect. Let me also import the logger, and I will log some info to indicate the mongoose and express are initiated. So let's call logger.log with mongoose is initiated message. And let me also log a message, express app initiated. So the idea is this loader will be responsible for bootstrapping whatever is needed for the application. And as you can see, it's loading Express and Mongoose, and it logs once they are initiated. So in the next video, I will replace some of the codes in the index file with the loader. So in this video, I'll replace some of the code in the index file with the loader I created. First, let me create a start server function here so that the code isn't scattered all over the place and it will be easier to test it later. First things first, let me import the loader. Now I am going to call the loader here. Also, I'm going to need to import Express. So here, let me call Express. Now I can pass the Express app to the loader. Let's structure the require statements to get rid of the linting errors. And we don't need the mongoose related implementation here. This should also be at the top. And the same goes for the logger import. The Express app should be created inside the start server function. So let's put it inside. This should also be inside the function. So let's cut it from here and paste it after loader. So the last thing I should add inside the function is the process event listener. Now I am going to move the start server function to the bottom. And I should pass the server to the exit handler function. Everything seems to be intact, so at the end of the file, let's call it the start server function. So it is simplified now to a single function, which is responsible for starting the server. And if I would like to test it at some point, it becomes easy since I can just call this function and make assertions. Also, there is no other unnecessary code in the index file. So let's start the server and check if everything is working. It looks like we have a logging error. So this should be info, not log. And now the error is gone, but Mongoose should have initiated first. Let's see why. Okay, I just remembered that we don't need this file. Now, let's head to the index file. And here, the start server function should be an async function. And I should also add await here. Okay, now it's logging just as expected. The unexpected error handler function should have a server argument. So add a server parameter here. Now I can just return a function that takes an error argument, which is basically a closure function that returns another function. Here, I can now call it by passing the server. So I think you understand why I did that, but if you don't, whenever an uncaught exception event is emitted, it calls this function with a single argument, which is an error. Now, the server is defined inside of the start function. It is not by default accessible here. So I need to define it as an argument. And for that, I created an additional function that takes a server parameter and it returns a function that takes an error so that it is convenient to be called by the event emitter. So this is all about loader, separation of concern, and writing testable functions. Event-driven architecture is a software architectural pattern where software components communicate with each other by exchanging events rather than direct method calls. In this architecture, there's a publisher and subscriber who communicates through events. It's more like a newsletter subscription where the publisher notifies subscribers when a new story is out. Using this architecture is beneficial for many reasons, such as creating loosely coupled or independent components that are easy to maintain, easy for horizontal scaling where components can be added easily by subscribing to relevant events. Components can react immediately to events they receive, enabling faster response times, and it is easy to add new functionality or features without modifying existing components. Node.js provides a built-in events module that enables event-driven communication. We first import the events module and create a new instance of event emitter, and then you can subscribe to events using .on, and you can use emit to fire events. Now, let's see event-driven architecture in a real-world scenario. Let's take the create user function as an example. It is simple for now, but we might want to do several other things when a user is registered. For example, sending an email. If you keep adding things here, of course it will get bulky and we don't want that. So let's start by sending an email when a user registers. I'm going to use a package called NodeMailer for sending the email. In the meantime, inside the utils directory, let's create email transport.js file, which is responsible for creating a transporter for the email. Now I'm going to import NodeMailer. Let's create a transport and assign it to NodeMailer.createTransport, which takes an object of options such as the email service, which is Gmail. The next configuration is the auth, which defines the user credentials, such as the user email address and the password. Now, let me export the transport I just created. Now, let's store the credential in the .env file. So let me add the email password and also just the email. I'm typing mine. You can also enter yours. I also need to export both from the config file. So here, the email is invarse.email, and the password is invarse.emailpassword. The next step is to replace both the email and password with the value stored in the config. I'm going to import the config file. And this should be replaced with config.email. Also, this one with config.email password. Here, the import statement is not being used, so let me remove it. Let's now implement the functionality to send email. First, let me import the transporter from the email transport file. Let's rename this as transporter rather than transport. And the file name also should be email transporter. I am going to send the email using transporter.sendMail. Then you can pass the options. The first option is where the email is sent from. So let me import the config file, and I will add the value by using it. Now I'm going to assign it config.email, and 2 is the receiver email, which is user.email. The next parameter is the subject, so I will keep it to a simple message saying successfully registered. And the last parameter is a text, which is the body of the email saying thanks for signing up. Okay, we're pretty much done. I just forgot to add a wait here. Let me clean up the terminal and run the lint fix. Everything seems to be clean, so let's start the server. And let's test it by sending the register request. It is saying username and password are not accepted, and that's because Gmail is blocking our application. So to fix that, go to your Google account security and click on two-step verification. Turn it on, then you'll be presented with this page. And you will find something that says app password at the very bottom. Here, select Gmail and also the device you use, or I could just give it a name. I am going to call it Node Mailer. As you can see, it generates a password, and I will replace the password in the environment file with this password and test it again. It's taking some time. And here you go. It's working now, so let me check my email. You can see that the email has been sent successfully. So in the next video, we'll see how we can improve this using event-driven architecture. So I'll continue by making it event-driven, and it will make so much change in the architecture and also the speed. But let me start by creating an event emitter file inside the utils directory. Now I'm going to import the events module and assign it to the event emitter variable. Next, I'll export a new instance of this event emitter. So this creates a global event emitter instance, which is going to be used throughout the entire project. Now, let me create a subscribers directory in the src folder, where we'll add all the event subscribers. So let's create a user.js file. Here, let me create a signup function, which is an asynchronous function that is responsible for sending the email. Okay, let's head to the user service and copy and paste this into the signup function. And I need to copy these two import statements as well. So the signup function takes a user argument. Now I'm going to export it. Let me make this a capital letter since both the event name and handler are signup, so this will differentiate them a little bit. Here, we export the event name as the property or attribute and the event handler as the value. So inside the user service, let me import the event emitter from the event emitter file inside the utils directory. Let me call event emitter.emit and pass the event name, which is signup. The emit function will fire up a signup event, which calls the signup event handler, and to call the signup function, we need to add it to an event listener. I will import the subscribers from the user file inside the subscribers directory. And here, I will add a listener for all the events. So let me call object.keys of subscribers, which will give us an array of event names. And inside the for loop, I'm going to add a function that assigns a listener to the event names. Before that, I need to import the global event emitter object I created. Now, let me call event emitter.on and pass the event name and the subscriber or the event handler. So it loops through an array of event names and assigns them a listener using event emitter.on, and subscribers of the event name will return the event handler function. Since we added it in the loader, it will listen to events before they are fired. So now let's add an index file in the subscriber folder that will export all the files. I'm going to import the user.js file, and that's the only file we got here. Now, let me export it. So when the application requirement grows, it will not just be one subscriber, so it's best to import all subscribers here and export them in one file. And this can now directly point to the index file I just created. Let's test it by sending the register request. It registers the user, but it's showing an error in the terminal. The problem is that the user is not being passed when firing the event. So let me pass the user here, and I will send the request again. You can see now how fast it's responding, and this is one of the many reasons to use event-driven architecture. It's also sending the email successfully, and this is all about event-driven architecture. I hope you enjoyed it.